Hello folks, how's it going? This is Mike with another video on Foundations of Math 2. In the previous video we talked about the set of irrational numbers. We gave a sense of a definition as to what an irrational number is, and we talked about how do those things work with our basic operations: addition, subtraction, multiplication, and division. This is going to be a fairly short video. We're going to talk about the real numbers. We're going to talk about how they relate to the other sets of numbers we have talked about earlier on in this chapter, and then just some basic general properties that we have for all real numbers. So, the real numbers, in some sense of a simple definition, is the union of the set of rational numbers and the set of irrational numbers. But how do these sets relate to each other? And I'm not talking just the set of rational numbers and the set of irrational numbers. I'm talking the set of natural numbers, the set of whole numbers, the set of integers, the set of rational numbers, set of irrational numbers, and the set of real numbers. Well, I've provided a fairly involved diagram here to show you how these sets relate to each other. What's actually happening here is that these sets are subsets of each other. N is the set of counting numbers or the set of natural numbers. W, the set of whole numbers, is all the natural numbers, but including 0 as well. So n, the natural numbers, is a subset of the set of whole numbers. The integers, z, contains all whole numbers, but then also the additive inverses of every natural number. So w is a subset of z. Every integer, every guy in the set z, can be written as a rational number. The denominator of that fraction would just be 1. So z is actually a subset of the set of rational numbers. Z, the set of integers, is a subset of q. And then the rationals are a subset of the set of real numbers. So, not that it's the most crucial thing to know in the world for this course, but I just want to at least have you see how these various sets relate to each other. So the set of real numbers is a very nice set, and I mean very nice in the sense that there are a list of properties or facts that are true regardless of the specific real numbers that we choose. And we're going to go through those properties now. First one is the closure property of addition and multiplication. If you pick any two real numbers a and b, if you take their sum, you're going to get a real number, and if you take their product, you're going to get a real number. So sums and products of real numbers are real numbers. 2, the commutative property of addition and multiplication. Commutative property basically says the order in which you add things or multiply things does not matter. For any real numbers a and b, a plus b equals b plus a, and a times b equals b times a. The third property, the associative property of addition and multiplication. Associative property basically says if you're taking the sum or the product of three numbers, whichever ones you add or multiply first really does not matter. It doesn't impact the end result. It's going to be the same thing either way. So a plus b plus c is equal to a plus b plus c. And similarly, a times b times c is equal to a times b times c. That's what the associative property is saying. The set of real numbers has the additive identity property. For any real number A, there is a number, which we obviously know as 0, such that if you add 0 onto any number A, you just get that same number A itself. So A plus 0 equals 0 plus A is equal to A. We call 0 the identity for addition or the additive identity. And we have a multiplicative identity, such that if you take any number and multiply it by this multiplicative identity, you'll get that same number back. Obviously, this number is 1. We call 1 the identity for multiplication or the multiplicative identity. And we see that A times 1 equals 1 times A, which is A. We have, for every real number in here, we have an additive inverse. For any real number A, there is a number minus A, such that when you add these numbers, you get the additive identity 0, and this number minus A, as we said, we call the additive inverse. 7, there is a multiplicative inverse for every real number except the additive identity, except for 0. That multiplicative inverse is 1 over A, and when you multiply A and its multiplicative inverse, you get the multiplicative identity 1. And the last property here, the distributive property of multiplication over addition for any real numbers A, B, and C. If I do A times the quantity B plus C, this is equal to A times B plus A times C, and that also works if I switched B plus C, that quantity, times A. Still gives me that same thing. Now, why do we list out all these properties? Well, for those folks who go on to take higher level math courses, really advanced math courses, there is a whole course that focuses on whether certain sets or certain collections of mathematical objects contains these properties. I'm not sure if anyone here is going to go on and take that high level of a math course, but these properties are the necessary properties for a set of numbers as well as some operations to be considered what's known as a field. That's all I'm going to go into detail on that. Anything more would be way beyond the scope of this course. But these are just general properties that you will want to keep in mind and you will want to use throughout this course. Mainly things like the closure property, the commutative property, and the associative property, the distributive property as well, there at the end. These are the types of things that you'll just want to keep in mind that, hey, we can do these things with real numbers. So this concludes our video on the real numbers. I just wanted to show you how this set relates to the other sets we had talked about, and then some basic yet very important properties of the set of real numbers. If you have any questions or comments, please be sure to reach out to me, guys, any way, shape, or form. Fly to my house, knock on my door, send a rocket to my house, text, messages in the clouds, whatever you have to do. Otherwise, until the next video, take it easy.